Thank everybody for making it here today. I want to talk a little bit out of track. I want to talk kind of to manufacturing today, although I think the topic applies very well to a lot of the stuff that's also happening in smart buildings and connected facilities. We certainly see these same challenges that we'll talk about today on the same opportunity with the edge in both use cases and both environments. My name's Allsbrook. I'm the CTO at a company here just a few blocks up the road called Clearblade. We are an IoT software company. We've been doing enterprise software for years and years now. And my background has lived and breathed in that space. So if you were just in the last session where they talked a lot about the integration challenges, well, integration's not a new problem. It's something that a lot of folks have been working on and will continue to be a big challenge and a big part of what IoT does and solves. So the topic at hand today is around edge. Specifically, what is the value proposition of the edge? I've heard a lot of really good stuff said. I heard GE talk about what edge is going to mean to them that they're working on now. I've heard a lot of folks, we had a session yesterday about the intelligent edge and the value that you can get there. I'm going to specifically talk about just the security aspect of it. A lot of folks are worried about another layer, adds complexity, gets more security issues. Other folks are worried about, what else can I get out of it? Why do I even need to waste time? The cloud's supposed to solve all these problems. So securing and optimizing your manufacturing facilities, or if you're out of the buildings, folks, you can say connected facilities with the IoT edge. If you're like me, you might have been writing code or you might have been working on factories and manufacturing for years, and suddenly everyone's talking about Industry 4.0, and you thought, I should go Google Industry 4.0. I don't know what's different. So I did, and this is what Wikipedia came back to us, and it said, here's the ranges of the industry, the revolutions we've had, and the fourth industrial revolution is Cyberphysical Systems. So Googling didn't help me because I didn't know what Cyberphysical Systems were either when it was all said and done. So I dug into that more, and I learned there's really four core elements that differentiate the third awesome robots putting pieces together from what this cyber-physical system future of the industry is. Those four elements, first is integration. We heard these gentlemen in the last session talk about integration, integration, integration. Ultimately, all of these machines, the products that are going in there, the things that are building are going to be integrated. That's a first step of Industry 4.0. The other thing that we see out of that is transparency. Right now, that machine in the third generation, if I go into factories today and you ask what's the status of my work order that I just bought online, they'll say, I don't know. We go look at a system and it's 2 days old. And we don't know what those machines are doing or where it is. Transparency becomes a big part of changing these manufacturing facilities with the ability to know exactly where everything is, the exact state of what's going on at all times. Sometimes they call that a digital twin, a device shadow, the ability to look in and see what's going on. Third element of this cyber-physical system is the ability to help the workers and the facility managers. There were some folks alluding to, we're going to get rid of jobs with all this, and certainly we're going to optimize, but we're also going to really empower the people that are there. You're going to be able to look at the machine, and you're going to be able to see the instructions to fix the problem. You know it's too hot, it's been diagnosed, you know you need to change this air filter. So you're going to be able to really optimize the process as it goes through. So that becomes an important part of the overall thing. And then finally, and this is where it gets exciting for the edge, is we're not going to go and make all the decisions from corporate headquarters. We're going to move the decisioning down. And so this is the fourth point of cyber-physical systems is we're going to move those decisions down closer and closer to the machines and stuff that need to make them. This is intelligence. This is edge processing. And ultimately, it's going to advance over time. Right now, we just want to move that if statement down a few levels, get the if statement closer. But ultimately, we want to move that Bayesian algorithm, that neural network closer and closer. So that helped me tremendously. I at least learned out of this session what all that was because I had to check out what Industry 4.0 meant. But then I went and I stared, well, why does anyone in industry care about IoT? What's industrial IoT specifically? It's much easier to go to Best Buy and look at all the cool nests and figure out what I'm going to get out of it. But I like to think about an industrial IoT product, and I'll first say who's going to use it. Well, that's the end user. Ideally, you make a product that delights that end user. The end user isn't always a homeowner. Very often, it's a factory floor worker. It's a facility manager. It's a hospital, a nurse in a hospital. These roles that are going to be able to do their jobs better. They're the first person to get ROI out of an industrial factory manufacturing facility that's got IoT enabled. If this was a commercial product, it stops there. Or a home product would stop there. But instead, being part of the industrial world, there's a whole nother piece. There's the whole vendors that create the ecosystem or build the products that are going to run in those manufacturing facilities. So if you're in a building, you have escalators. If you're in a factory, you have kilns. If you're on a job site, you have trucks. All of these things are products made by someone else who are now going to be made better. They're going to have better maintenance cycles. They're going to be made more aware. They're going to give you, they're going to have better products overall. So there's a lot of opportunities for vendors to delight their end users, but they're the ones who get the ROI out of this investment. And the last piece is the overall ecosystem that comes out of this. This is really that integration that we started to see, and that was we are not just building a Nest camera. We are not just making a better connected escalator. We're building an ecosystem of a building where the elevators talk to the escalators, talk to the visual, the facial recognition, a factory where the kiln talks to the Scrum tools that you're using to Kanban your process across. You're talking to the EMS. You're sending just the data about temperatures to the emergency management systems. There's a whole ecosystem that gets built and gets value. I think this is incredibly compelling because in the last session we were asking ourselves, who is getting the ROI? What's the driver in this? It's much easier to find the driver when you have 3 interested stakeholders all saving money or getting value out of it. So that's why manufacturing IoT is so exciting. There's a lot of stuff that we can do. So I'm going to get a little more technical here. It's not MART lighting, it's actually smart lighting, but that's over off to the side a little bit. But I want to talk about what smart lighting looks like as a general deployment. I drew this up. There's actually a light bulb and a mobile app on the other side of the image as well. And that is things. There are things sitting down at one end of our smart lighting solution. This is why we're buying IoT. This is why we're investing in it, to have these things automatically talk, get rid of wires. Zigbee maybe by the solution here. They're all going to talk a protocol to a gateway device. That gateway device, that's kind of going to represent our edge here, but then they're also going to do cloud logic. And then ultimately, they've got to present back to the enterprise, the industrial user at the end. And so there's always this, in this case, APIs and dashboards. So this looks like a lot of the smart lighting solutions I've seen. Hopefully you've seen them. You kind of see this same level of infrastructure. Let's take another example of often see in factories and buildings, chillers and HVAC systems, right? How do these things break down? Yet again, on that left-hand side, the chiller is now not kind of a very lightweight light bulb. It's a gigantic machine. It's processing and doing lots of stuff, lots of data coming off of it, but it's still that thing in our ecosystem that used to not be connected. What we see is that chiller communicates, or sets of chillers begin communicating with, and I mixed up my slide here, it should be the monitors next. So the monitors are basically pulling that data in and then ultimately moving it to the servers. And once again, the value prop for the enterprise is being able to expose it, put the reports up, the fat client apps, however you want to look at that data in the business, that shows up on the enterprise side. I give both of these examples to point towards the abstraction of the problem. There actually generally looks at 4 layers of a problem. I see these 4 layers over and over and over again. You first see the things. This is what we're excited about. In manufacturing, this might be Allen Bradley machines spewing OPC UA. They could be newer machines and they're running MT Connect over IP. They could be a building running BACnet. It's usually an ecosystem. It's not just one. It's lots of different protocols all coming together. And now this is where we see the edge. We see this opportunity to have a gateway in a place and an edge. This is where, if you just take it as a gateway, all we're doing is translating a protocol. So if we don't take advantage of those things that we talked about and led with, which is securing and optimizing, if we just use it as that, all we're going to do is transfer that protocol to the internet and run over to some server platform. Server platforms, we've been building them for years. If you're in IT, you're very aware of the middleware you've been buying from Oracle or from IBM or whoever your favorite vendor is. You've been buying those, putting them in place, and this is what all of your data is going to roll up into. And then ultimately, if you're building the IoT, that'll be new, but then it's got to go talk to those systems. You want to continue to use J.D. Edwards in a factory instance. You want to continue to use those tools that you've been optimizing your business with for years. So that is a fundamental piece of the real enterprise industrial IoT architectures, is to include that enterprise application. So I've said all this to set the stage of what could we do, what are we capable of doing with that new edge piece in the middle. So let's start with security. I would imagine everybody's read an article about security lately. It's kind of a big deal in IoT. Pretty much everyone asks. So security is a real problem. Data is getting compromised, devices are being hacked, and if we don't think about security out of this base architecture, we miss a real opportunity to protect ourselves and our investments, especially in the industrial world where it's not just that my lights got hacked or that my camera is now being put on the public internet, which is pretty bad, but now it's our machines in our factory shut down. And those folks know down to the dollar every minute when your factory's not running. So if we look at the architecture, we see those things. I talked about the local protocols. I wish I could say every local protocol was secure. I wish I could say the protocols we put into place in 1981 were encrypted and you know, require two-factor auth, but the fact is they don't. It's brownfield, there's a mess there, and you got to put them all together. So those things roll out, but we have a chance. We have a chance with the edge to secure them. But the internet is not a safe place, right? This is what we know about. We've seen this. We've seen the data be compromised. We've seen people forget to do security. There's all kinds of issues. But the nice thing is that edge is that first point. So when we look at what we can do there to both prevent attacks against our internal industrial networks, we have first the opportunity for our edge to behave outward. Nothing drives me more nuts is when you find out someone lets your edge endpoint be accessed externally. Should never be able to do that. You have to focus that edge outward. It has to reach out to the cloud, to the server infrastructure over the internet. So we have a chance to put those rules in place at the edge. The other thing that we can do is we then can enforce authentication. We've been running dumb devices for years. Those devices have no idea who they are. They don't understand anything about OAuth. But we have a chance with that edge to give the first-class nature to those devices that are in the factory. So not only can we use the new devices from TI and Intel, if you've seen that, I've seen some awesome stuff with security all built in, but we can merge those ecosystems into a common spot here at the edge with authentication, and that always leads to authorization. It's always funny. I've yet to see the use case in real life, but a lot of these situations, they'll give credentials to these devices, and these devices would have access to update the user registries. So literally, you're asking yourself, why are you opening this capability? You're just making vulnerabilities for your overall infrastructure by doing it that way. So this basically means we're going to say the device is pretty much smart enough to say, I'm turned on or I'm turned off in terms of what I'm doing as a function. We're not going to over-empower those different devices. Then that leads to the next idea of encryption. You can't go back and make those old machines encrypt what they're doing. You can't go back and put encryption on old protocols. You can say, once this thing leaves the safety of my factory or my facility, from here on out, it's going to be encrypted. So you can transfer that payload, add the encryption to it, and make sure it rolls securely over, so that if you do have people looking at the wires, you do have potentially a compromised situation, they're not going to get anything of value. And then the last piece of that is you also have the opportunity to store data locally. If you're really going to decision there, you're going to do your big data algorithms, there's data that's going to be there. You can't execute and build these things without letting stuff sit on those drives. And so you have to think about rest and encryption of data at rest as well. So yes, the edge represents a new layer in our architectures, but in a lot of ways, it's the layer we desperately need to fix the security problem we have. All right? Certainly, there's security on other ends of this, but with regards to the edge, you can bring a lot of normalization best practices. Next is what the edge can do for performance. I first made this chart last summer. It was not popular to say edge. I tend to pick things that aren't popular and decide to talk about those. So I made this chart last summer about the challenge of trying to use a cloud-only solution in IoT, because that certainly was the popular way to view the world. This case shows a nice little sensor temperature sensor doing its job in a factory. And it's going to say, hey, the temperature is now 82 degrees. And that slide used to build a little more slowly, but it built all at once, so I'll talk through what happened. So the temperature sends its data across. It hits that edge device. It takes about 4 milliseconds. That's awesome, right? We're not talking RTOS yet, but we're talking this is faster than the internet normally behaves. But now we're going to roll over the open wire, and it's going to take us some time across our great network providers, and we're going to burn 110 milliseconds, 140 milliseconds, or 110 to our cloud provider. And then it's going to take, we got to bounce that to an API manager. We want to do security, so we're going to use our API manager tools. All right, that takes a little more other hop. And then we got to go somewhere else to run our rule engine. We want to say, if the temperature is above a certain amount, turn the fan on higher. So we engage our microservice rule, or serverless rule, however you call that, or whatever tool you use. And of course, that server tool says, well, I want to do some big data calculations. I'm going to pull about 2 meg out of the database and run across it real quickly so I can make this decision. It will be using some neural network for this decision. And so then it says, ooh, that was a big payload. We're coming out at 400 milliseconds just to get that data through the cycle. And of course, we got to process it again and then roll it out the way it came, because that's how the internet works. And so by the time that thing just gets back to our factory, we spent 3 seconds to say, turn on the fan. Right? And then we got to hop the message all the way down to the actual device. So that's kind of a painful story. Now, you may not care if it takes 3 seconds for your fan to come on, and if it happens automatically, that's all right. But if you wanted the fan to turn on and you hit the button and you waited 3 seconds, you probably would have hit it 6 more times wondering why it wasn't on. So that's a problem. And so for the edge, there's a real opportunity to short circuit that whole right half. There's a lot of value in that right half. There's a lot of things you want to do all the way up to the cloud, to your enterprise. But for situations like this, wouldn't it have been better if we could have moved it all to the local edge, done that processing there, run that Bayesian algorithm for deciding whether the fan should be on or off based upon the temperature in June, and then issue the command. So there what we see is it wasn't a 3-second latency, it was a 10 millisecond latency. Right? Again, kind of a contrived example, but when you're talking about safety, when you're talking about issues of performance, when you're talking about user satisfaction and how they perceive the system, this is incredibly important. That's performance. So we talk about security, we talk about performance. Let's talk about the durability of IoT. I don't know if you're like me. You were using your normal everyday jobs a few weeks ago. And for us, I couldn't put photos on my hip chat, which meant I couldn't say all the funny jokes I wanted to say, and I don't know why that was working, but what it actually was is Amazon S3 went down on the East Coast, and suddenly lots and lots of businesses couldn't do their jobs. So for Clearblade, it cost us the fact that I couldn't tell funny stories on our chat tool. But for a lot of companies, it cost them a lot of money, right? They were basically out of processing. And so in this case, if you think about a building, just trying to unlock a door, if you're dependent on a cloud for a situation where you want to unlock a door, and this is absolutely a situation and a use case that people built around, you have a really high pain point standing outside your building wishing the door would unlock when the internet's not, or the cloud's not there, okay? In this case, the case I was talking about was just one cloud service provider. But certainly we all have ISPs that I'm sure we all love tremendously. Oops. We all have ISPs, but my internet goes out at home every now and then. Drives me crazy, and I can't watch Netflix. But in a factory, yet again, if you can't run your business and your job because you're going to tie your business to these particular situations, you're going to have factory outages. You can't print your labels. You can't turn your machines on. You can't analyze your machines to see if they're behaving normally. So you've got to move a good portion of that function, at least strategically, down to that edge. So if I draw that picture again more generically, what you see here is even when you have an external outage on that right-hand side, if you've been able to move down the strategic pieces of auth, the strategic pieces of compute you want to do, rather than going up to a Lambda instance or server, you can run it all locally. If you have the right amount of storage, and that's not a lot you need for a lot of this stuff, and you can route the APIs and say, don't go to the cloud, solve this problem here, you can actually keep your doors unlocked, you can turn your machines off and on, you can keep the 100% uptime. All right? And so that's a pretty bold claim to say, I can now have my IoT solution that works without the I, right? That's pretty cool. And then, of course, you've got to be able to sync up when it's all said and done. But that's what the edge can give you. You can really optimize what's going on in your factory if you can perform these core elements of the solution you want at the edge. So I'll jump into one last idea, and it's less practical and more just real life. Maybe those things mean the same thing, but really what we've seen, at least at Clearblade, is nothing sneakier than my cloud bill. Nothing is better than when I give my developers the credentials to go create some new compute, and we all have a $15 bill in April, and next month suddenly it got to be $4,000, and I say, what happened? And that's because these things grow, right? We run a test case on the cloud, and we keep it running because we wanted to see how long it would go. Suddenly that bill gets very, very expensive, that little bit of usage bill. That's okay for a cloud development company. We're doing dev and test to experience that. We can always turn it down. But if you design your long-term industrial solutions such that they run with this fat pipe of data, ingress, egress, transactional behavior all being done, costing you little pennies at a time, that bill gets enormous, right? It ruins the ROI of the use case you wanted to talk about in the first place. So you have to think about, what could I use the edge for to actually keep that nice little small line that we got the value out of and we saw our overall solution? How can we keep that use case and yet still deploy this IoT solution, industrial IoT solution, in our manufacturing facilities that we wanted? And so the idea here is if we can push that stuff down, and we can use that edge, the compute we have there, the ability to run our logic, the ability then to do things like compress the data, filter the data. I love the use cases where I find out that light bulb has not moved 10,000 times in the last 2 minutes. Why did we tell anyone, I haven't moved, I haven't moved, I haven't moved, I haven't moved, right? Why do I being told it's on? The reality is that device is too stupid to know whether you want to know about it or not. It's just going to keep telling you. So you have to be able to have something at that edge to thin down that noise and make it be basically what you care about, right? Did the device state actually change? Very often that's what we're interested in. Did the device state move outside of a threshold we wanted to have? So that's where you can take the edge processing and really optimize your overall IoT solution. and then ultimately still use the infrastructure you had in the past. So I just got the 5-minute warning, and I'm done. So maybe I'll open it up for questions and see what else you guys might have, if that made sense, or use cases you're interested in. Or I'll give you 5 minutes back and you can get on track.
I just have a curiosity.
Sure.
On one of your slides, when you were talking about before the edge came in, the kind of historical model of the thing, you talked about the time it takes 30 seconds, right?
Mm-hmm.
And why is data going back to the local? Because, yeah, you had all that,
Yep.
right? So why is it taking 400 milliseconds? What's data needs to be shipped back? Because in theory, all the factory is asking about is should I turn it off or on temperature? What data is in theory?
So it's always surprising when you think, yes, and if this, then that rule is simple, right? An if statement. But what we find is a lot of companies want to not just do that. They want to say, well, let's go back and look historically and say, well, let's look at all the temperatures over the last year by month and make this decision. It start to be more and more variables. I'll go to a fun example of I worked on some dating algorithms, and you would think pretty much if we both like pizza and we both went to UT, we should be a match. The reality is there's way more behind what might be going on if you think about it in that sort of scenario. So while this was simple, there are many, many use cases, and especially in these factory worlds, where you actually are going to be going and looking at large data sets to understand what decision you want to make. And really, if you think about what AI is, it's actually a set of 17 very well-known mathematical algorithms that run across big data sets. So really, that's kind of representing there is a lot of behavior that has to go across this, not only to get the context of who this temperature sensor is, who this fan is, what this factory is doing, where are we currently in our cycle, but also then bringing in those new data sets of historical information. Does that help answer that question?
So in the edge, then, are you saying that all these steps historically that had to be pushed out, you are bringing it all?
We're absolutely seeing that. We're absolutely seeing that. Yep. So you don't have to, you can do the security layer at the edge and decide not to send it out. You can run your logic to say, I want to run a Bayesian mathematical model across this data set, and I'm going to do it here. You have the capability to begin pushing that stuff down all the way to the edge.
And storing in the edge, too?
Mm-hmm. Yes?
So I'm behind the idea that you need an edge. One of the things that I'm a bit a challenge is the dollar as an issue from an edge perspective, because the other flip of the coin is that, people go to the cloud to not have a dedicated IT and, all this stuff. So how is that not going to creep back into them now have to invest lots of money into an IT on the side? So there are needed needs for the edge regardless of the dollar sign, but I think the dollar, I'm kind of like on the edge with this one. It's not really a clear cut for me. That's a good argument for the edge.
So I don't want to pitch my product, but I'll tell you how I solve that problem. I think when you look at edge providers out there, anyone you might know of, you should look for folks that make it very easy for you to manage. The same way you write a serverless function in Lambda, you should look for them to be able to put that on your edge for you. You should look for the ability to have a lot of flexibility in how you move that logic down. You're absolutely right. Nobody wants to go back to buying. I mean, I thankfully haven't had to do that task. I got 1 minute, so I'm going to go quick. But you don't want to go back to that stress of having to put all that infrastructure in. We are going to see these things go in. Quite frankly, the edge is already there. Cisco's putting in routers and stuff. There's processing there sitting, waiting to be used. So it's just a matter of how are you going to leverage that. So when you look at, if you're going to build applications, and that's what we're talking about here, applications, you should look for folks who can help you make that application logic as easily cloud managed as possible. Is that fair?
Yes.
Okay, so that's how we see the problem today, and how we're helping solve it. Because we certainly don't want to go back to having to put IT in every factory. Those guys don't want you there anyway, right? So, all right, I'm done. Thanks, guys. I appreciate it. Thank you very much for coming.